It's a process. It's a process data. So it is organized, and we have seen examples on that. And we also discussed about the types of data, different types of data: qualitative data, quantitative data, structured, unstructured, semi-structured data we have seen. Okay, so qualitative, okay, just see the main types here. Structured data stored in tabular format. Okay, that is well organized in tables, rows and columns format. Okay, so that is called structured data. So unstructured in the sense data with no predefined format. It has no fixed format. Okay, so examples are here: videos, images, PDF files, like that. Okay, semi-structured, it is not fully structured like tables, but still has some organized tags and markers. We have seen the examples XML, JSON also. Okay, so that is about data. Then what is a database? It is an organized collection of data. So we have seen types of databases. Different types of databases are there. Okay, relational databases, NoSQL databases, hierarchical network, object oriented, different types of databases we covered. Okay, so we have seen each and everything. Okay, don't make it complicated. It is simply, see, in our childhood days in the schools, we used to maintain white pages book for mathematics, right? Double rule for other languages, and 4 rule book it is for English, and also broad rule for Hindi language. Okay, in the same way, see, if we use double rule or single rule like that for mathematics, it doesn't fit also. Okay, we have, for mathematics we use white pages, left side, right side we give margins, and we use it, right? So for Hindi, broad rule we use. So based on the content, based on the type of the content we used. Okay, in the same way here, type of the data, based on the type of the data, the database we use. If it is relational, then relational databases we use. Okay, let me see here. Let me show the PPT here. See, structured. That means tabular format. Unstructured, semi-structured, unstructured. Here, videos, images, audio files, messages. These kind of things comes under unstructured. Semi-structured, it supports XML, JSON. So depends upon the type of the data, the database changes. In the same way. So DBMS, when we discuss about DBMS, so it is for mainly to manage the database management system. What does it mean? Database management system. So the name itself says it is for managing databases. Which type of databases? If it is relational database, then it becomes a relational database management system. If it is for some other thing, or no structured or structured, let me show you here. If it is relational database, so relational database management system, that's a software through which we operate on relational database. Okay, here relational database management system, we use a particular language called structured query language to communicate with the database, relational database. Okay, in the same way, we have unstructured and structured, unstructured and semi-structured format here, that is called NoSQL database. And to manage these databases, we have NoSQL database management system. Okay, it does not have a particular language to communicate with the databases. Depends upon the company. They designed it. Okay, they developed their own language. MongoDB, they developed a Mongo query language to communicate with the database, as well as Cassandra developed their Cassandra query language to communicate with the NoSQL database. Okay, and we also seen the what features. Okay, features we have seen, and evolution of database management. See, we also covered that. Okay, now let us start relational database management system. Relational database management system. Okay. What is relational database management system? Okay. It is a type of DBMS that stores data in the form of tables. Okay, it is a type of DBMS that stores data in the form of tables. Who is this? Vallepu Navi. Why these are coming? Okay. Next, it is a type of DBMS that stores data in the form of tables. Okay. Next, what is relational? The relational part means data in different tables. Okay, is connected. That means related. Okay, through keys. Okay, through keys. That is relational database management system. Okay, so here this concept of RDBMS so was introduced by Edgar Frank. Okay, Edgar Frank Cod. Okay, we call him as EF Cod. Okay, so at the time he was a scientist in IBM company. He was a scientist at that time. Okay, so he developed this RDBMS concept. Okay, so he also created 12 rules. Okay, we call them as CORDS rules. Rules. So these, if any database that follows these 12 rules, that database will be called as perfect RDBMS. Okay, a database that follows all 12 rules, then that's a perfect RDBMS. Okay, perfect RDBMS. Okay. Now here let me show you. So these are the rules, 12 rules we have. Okay, let's see the rules. The first rules, let us see. Rule 1 is information rule. What it is? Information rule. Okay, information rule. What it says is all data should be stored in tables. That means rows and columns, right? Rows and columns. All data should be stored in tables. Okay, here let me copy the tables here I created. See, here we have one table here. We have one table here. Let's see this. EMP-ID, ename, job we have. Okay, and we have 3 records here. Okay, that means these are called as rows. Okay, rows, we call them as rows or row. Okay, here we have 3 rows or 3 records or tuples. We call them as tuples. Okay, this is one row, this is another row, this is another row. Okay, record, 3 records are there. Each one is a record or tuple. We call them as tuple also. Okay, 3 records are there. And what about this? Let me see. E-name we have, employee ID we have, job we have. What about them? What about them? We call them as columns. We call them as columns. Job is a column. E-name is a column. EMP ID is a column. Or fields. Okay. Or attributes. Okay. We call them as attributes, fields, or columns. Okay. Usually we call them as rows and columns. Okay. Here 3 records, 3 rows are there, and 3 columns are there. 3 columns are there. Okay. Next, what is this? So here each row or record in the sense one employee record, right? Each row or record in the sense what? One employee record. Here 3 employee records are there. If we have 10,000 employees, that means 10,000 employee records are there in the table. Okay, that means let's see, what is a table? Table means what? Collection of rows and columns. What is a row? Collection of field values. What is a row? Collection of field rows. See, field values. It's a collection of field values. Okay, then what is a column? Collection of values belongs to one field. Okay, one field. Collection of values belongs to one field. Okay, then what is database? Collection of tables. Database is, it's a collection of tables. Table in the sense collection of rows and columns, and the rows in the sense collection of field values. Column in the sense collection of values belongs to one field. Okay, so let me show you that here. See, database. I open database here. Let's open employee DB. Under this we have tables. Okay, here we have tables. Here we have many tables. Let me open one table here. Okay, let me open this one. Table. Okay, it's an employee table. It's an employee table. Wait, it has data also. Wait, it's a little bit slow. Yeah. Okay, see, now we have data. 12 rows are there. And employee ID, it's a column. Employee name, it's a column. Job column, salary column we have, and 12 rows are there. 12 records are there. Okay, 12 records are there. Okay, so that means database collection of tables collection of rows and columns. Row in the sense collection of field values. Column in the sense collection of values belongs to one field. And the next rule is rule 2, guaranteed access rule. Guaranteed access rule. Okay, guaranteed access rule. What it says is every table must contain primary key to identify the records uniquely. What it says, every table must contain a primary key to identify the records uniquely. Okay, uniquely. Let me copy this table here. This is another table. See, here we have employee name, job title, salary we have. Okay, and also date of joining also we have. Okay, so here 3 records are there. Okay, assume that a company have 10,000 employees are there. Company have 10,000 employees working in that company. Okay, so let's assume there may be number of employees with the same name. There is a chance of having same date of joining or same salary. Okay, then if I want to update one record, how do we update that? Say here Rakesh V, same name. Here job title software engineer. Okay, software engineer. Perhaps if you take salary also, if it is 30,000, okay, same, there is a chance of having same salary, right? Date of joining also. When we have records like this, suppose if you want to update one record, how do we do that? So that's a problem, right? So in order to get rid of that problem, we have a concept, keys concept, primary key constraint. We call them as constraints concept. Okay, primary key we use here. Okay, suppose if I have employee ID, here you see in the database employee ID, we have employee ID. Uniquely we can identify record 102, that means second record. 103 means it uniquely we can identify this third record 103. Okay, in the same way here, if we have primary key, with that primary key we can uniquely identify a record. Okay, here, right? So if we have employee ID, one employee ID is given to one employee only, right? They don't give it to other employees. Okay, one employee have only one employee ID. Okay, so not only employee ID, even if you take government organizations or banks, income tax department, election department, whichever organization you take, they maintain primary keys. Example, bank uses account number. Right? Bank account number they use. Account number. Okay, and government organizations, if you take, they use Aadhaar card. They use Aadhaar card number. Okay, and income tax, PAN number they use. In the same way, different organizations, they use primary keys. Okay, even if you have serial number or any ID number, that will be considered as primary key. Finally, our intention is to identify the records uniquely. That's why this primary concept has come. Okay, that is the meaning of guaranteed access rule. And also here we can easily identify the record and we can easily update the record. Suppose if I want to update one record, we can write based on the condition employee ID equal to something. If it has employee ID, based on that employee ID we can update that. Okay, so we have different ways of maintaining primary keys. Okay, now Let's see RDBMS features also. RDBMS features. Okay. Now, what are the features of RDBMS? Easy to access and manipulate data. The first one is easy to access and manipulate data. Second one is less redundancy. Okay, less redundancy. That means redundancy in the sense duplication duplication of data. The third one is more security. Fourth one is guarantees data quality and consistency. Okay, that means data integrity. We call it as data integrity. And the fifth one is it supports data sharing. And sixth one is supports transactions. These are the features of RDBMS. Okay, these are the features of RDBMS. Let us see the first one. Easy to access and manipulate data. Actually, see, in RDBMS, data manipulation means working with the existing data inside the tables. Okay, that means adding, changing. Okay, that means updating or removing it. That means deleting. Okay, insert, update, delete. We call them as insert, update, delete. Okay, so it is easy to access and manipulate data. Okay, where this is a feature of RDBMS we are discussing. Okay, so in the olden days before RDBMS came into the market, working with the data was very hard. Okay, so to insert a new student information or update marks or delete a record, developers had to write long programs. So in traditional programming languages like COBOL and C language, etc., that time it was very difficult to work with the database. Okay, even for simple tasks also it was required to write big code, and expert programs were needed at that time. But after RDBMS came into the market, everything became easy. So instead of writing long programs, we just write short commands called SQL queries. We call them as SQL queries or commands. Okay, it is about easy to access and manipulate data. And the next one is less redundancy. What is less redundancy? Here, let me copy one table here. See, here we have one table, employee table. Okay, to make you understand this. Okay, this is employee table. Okay, here we have 100 employees here. Okay, so for all these 100 employees, department details are repeated. See, department number is repeated, department name is repeated, location is also repeated. Okay, so we have a problem with redundancy. See, redundancy, that means duplication of data. How many times we entered here? Suppose if we have 1 lakh records, then we need to change everything. Suppose if you need to change anything, so we have to change in all the records. Okay, so unnecessarily we are wasting the memory. Unnecessarily we are wasting the memory to store these details. And also another problem is if I want to change the department location, suppose here HYD Hyderabad it is there. I want to change this to Chennai. Chennai. Okay, then in 100 rows I need to update that, right? So deletion is also a problem. Deletion is also a problem. Okay, and one more thing is here one employee is resigned. One employee is resigned. Okay, so if I ask you a question, what is the department name? Okay, you can say that by seeing that in other record. By you can see and you can tell that HR department or location Hyderabad or department number 10. Okay, suppose all employees data it is not there, then how do you say this is HR department or it is Hyderabad location? We are losing that data also because of maintaining all the details in a single table. In a single table we are maintaining all the details. Okay, so we should not maintain all the details in a single table. Data redundancy will be there. Updation is also a problem. Okay, deletion is also another problem. So in order to solve this problem, RDBMS says create multiple tables. Create multiple tables. That means storing data in separate tables and link the tables and link the tables. How do we do that? How do we do that? The same information, okay, we can create two tables and we store that information. See here employee table it is there, employee ID we have, employee name, salary we have, department number we are maintaining. Okay, but see in the first table department name, location, they are unnecessarily we are maintaining here, unnecessarily we are maintaining. So for that what we are doing is we have created one more table, department table, and in that department table department number, department name, location we are maintaining. We are maintaining all these three records. Okay, and what RDBMS says is link these two tables. Link these two tables. How do we link? In the first table we have department number. See, in the second table department number, here also we are maintaining. Okay, here in the department table this department number is a primary key. With this primary key we can identify each record uniquely. In the same way, in the first table employee ID is primary key. To establish a relationship between these two tables, what we do is we maintain this department number in the employee table. Then this department number in employee table becomes a foreign key. We call it as foreign key. Okay, so finally what happens here? We have employees departments relationship. We have what we have, employees employees departments relationship we have. Okay, that means many employees can belong to okay, one department, right? One department. So establishing a relationship between two tables by using primary key. Okay, and we are using this primary key here in the first table, that is called foreign key. Okay, that is called that we have feature, second feature. Okay, less redundancy, to maintain less redundancy. Okay, and next one is here, third one is more security. More security, what does it mean? More security. RDBMS provides more security. It provides more security. See here, when I try to log in into the SQL server, it asked me the user ID and password. So after giving user ID and password, it gave me access to use these databases here, right? So that is the security what RDBMS is providing. It is same for SQL Server. It is same for Oracle, whatever database management system you take. It is same. Okay. And that is security. The next one is guaranteed data quality and consistency. Okay, guarantees data quality and consistency. Okay, RDBMS allows only valid data. Allows valid data. That means correct data. Okay, suppose let me give one example here. Okay, employee table. Okay, employee table. See here, we have employee table here. We have two records. The first record 100 employee ID, and the second record you see the same employee ID we have given in the second record also. Okay, so here we have the first one is same employee ID is given to second record also. Okay, that's wrong. We should not give like that. And here in the second record name is missed. Here name is missed, e-name is missed. Okay, and if you see the salary also, here first record it is okay, in the second record minus 2000. Salary must always be positive. Okay, so here we have three problems here in this table. Okay, what is this? Guarantees data quality and consistency. So in order to avoid these problems, RDBMS has given a solution, and that solution is called as data integrity. Okay, so RDBMS provides certain rules and constraints to ensure only valid data, is stored or not. Okay, for storing valid data, it is giving some rules and constraints. So here quality means only correct data. Okay, correct data, whereas data consistency means data is accurate and same across all parts of the system. Data is accurate and same across all parts of the system. Okay, let me write here. Quality means, okay, means only correct data. Okay, that means or let me write like this: meaningful data is allowed. Okay, data consistency means the data is accurate and it is same across all the tables, or all the parts of this system. Okay, that means tables. Okay, let me give an example here. Here we have, see, two tables we have. Just see, observe these two tables. Okay, the first table is employee table and the second one is a project table. In the first table, if you see, the first record is employee name is A and its department number in the record, if you see 10. Okay, this belongs to employee table. Okay, if you see the project table, here we have a project table name. Its name is project id.dev team. So here this employee is working in development team. Okay, so in this table also, if you see the record here his name is A, and if you see the department number 10, it displays 10. That means it is same across all the tables. That is called data consistency. That is called data consistency. Okay. Next, if you see data sharing, the next point is data sharing. Data sharing. Let me write here. Data sharing. So actually, in the real world, data is not used by one person alone, right? So it is not personal use. Okay, if you see the real world, okay, companies, or if you see the companies, their employees, managers, HR, finance applications, and even mobile applications also may need to access the same database. Okay, so RDBMS supports this. RDBMS supports this. It allows multiple users and applications to access and use the same data, okay, at the same time. It allows multiple users and applications to access and use the same data at the same time. That means data sharing. It supports data sharing. Okay, now the next one is supports transactions. What does it mean? Okay, it is not related to money transactions. Of course, it's a part of, if you take banking application, there it comes, no issue. Okay, but don't think it is only related to money transaction. Okay, let me write what is transaction here. A transaction is a group of one or more SQL operations, like insert, update, delete, okay, that are treated as one single unit of work. A transaction is a group of one or more SQL operations, insert, update, delete, group of SQL operations, insert, update, delete, that are treated as one single unit of work. Okay, one single unit of work. What does it mean? Here, actually, we have you might have studied ACID properties related to transaction. The properties of transaction you might have studied in your academic part. Okay, so what is a transaction? We have seen, if you see the properties of transaction, we call it as acid properties, ACID: atomicity, consistency, isolation, durability. Okay, atomicity in the sense all or nothing. Consistency in the sense database remains correct before and after also. Isolation in the sense transactions don't disturb each other, and the durability in the sense once done, it's permanent. If you see the first one, atomicity, all or nothing. That means here in transaction, operations must succeed together. Okay, or none should happen. Operations, all operations must succeed together, or none should happen. Okay, none should happen. Here, let me give one example. Bank transfer. Okay, bank transfer. It's an example. Okay, suppose we have two accounts, account A and account B, and we are transferring amount from account A to account B. Then in the first case, if you see, it has to deduct, suppose we are transferring 1000 rupees. We have to deduct 1000 rupees from account A. Okay. In the next step, what we do is add that 1000 rupees to account B. These two comes under one transaction only, single unit of work. It's a bank transfer. Okay. So here the thing is, both steps must succeed together. If anything wrong with this second step, then first step must roll back. That means it has to be cancelled. If there is something wrong with the second step, so it must cancel the first step. Okay, that's a transaction that we call it as a transaction. It has to execute both the statements or both the commands, and they must succeed together. It's a single unit of work. Okay, and if you see another example, movie ticket booking system. Okay, movie ticket booking system. Let's see. First one is check seat availability. The first step, check seat availability. Okay, availability. And the second one is, if it is available, reserve the seat. Okay, that means we are updating seat status. Okay, third one is make payment. Okay, that means insert into payment table. Okay, and fourth one is confirm booking. That means insert into booking table. Bookings table. Okay, so here four stages are there, but we execute these commands or these statements, okay, at a time, all together. If there is any problem with one statement or one command, okay, it has to cancel all the transaction. Okay, check seat availability. Okay, reserve seat, it is done. But if there is anything wrong with the payment, okay, make payment, it is in third stage. If there is something wrong with the payment, then it has to cancel that transaction. Altogether, it has to be succeeded. Otherwise, it has to cancel the entire thing. That is called a transaction. It supports transaction. Okay. So these are the features of RDBMS, Relational Database Management Systems features. Okay. Now, see, next one is RDBMS softwares. Okay. Softwares. First one is SQL Server. It is developed by Microsoft. Okay, and another is Oracle we have. Okay, and it is from Oracle Corporation. Okay, and MySQL, it is also from Oracle Corporation. Okay, next DB2. Okay, it is from IBM. And PostgreSQL we have. PostgreSQL. Okay, this is from PostgreSQL Global Development okay, Group. group, global development group. Okay, and RDS, it is from Amazon. These are the RDBMS softwares. Okay, and for NoSQL database also we have MongoDB and Cassandra. Okay, examples of examples of NoSQL databases. Okay, first one is MongoDB, and the second one is Cassandra. Okay, and till now we discussed about relational database management system, right? After that we have another thing, object relational database management system also. What we call it as object relational database management system. Okay, ORDBMS. What is this? Object relational DBMS. Okay, it is a combination of, okay, it is the combination of RDBMS and OOPS, object oriented programming. Okay, if you are aware of it, okay, good, otherwise no problem. Object oriented programming. Okay, it is combination of RDBMS, we discussed already about that, and OOPS. Okay, ORDBMS equal to RDBMS plus object oriented programming. What it is for object oriented programming is for reusability, and also it provides security. Okay, but here ORDBMS, if you see, it is combination of both. Okay, but RDBMS, it is providing security. RDBMS already providing security. Now it started using reusability, that is from object oriented programming. It's a feature of object oriented programming. Okay, so in ORDBMS, data is stored in tables as well as in objects also. It supports some features. Okay, it has taken reusability from OOPS concepts. Okay, OOPS concepts. Okay, now here we discussed about SQL Server, Oracle, MySQL, right? Now if you see, these softwares are partial ORDBMS. Okay, they support ORDBMS features also. What are they? SQL Server, it supports, and Oracle also it supports, and PostgreSQL supports ORDBMS features. Okay, but not completely. Okay, next, these are the softwares, SQL Server, Oracle, we call them as partial ORDBMS. Okay, they are partial ORDBMS. Now after that we also have object oriented relational database management system. What it is? Object oriented, okay, oriented relational database management system. It's an extension to ORDBMS. Okay, now it is a hybrid database model. Okay, so it is the combination of same RDBMS plus object oriented programming features. That means objects, classes, inheritance, encapsulation. Okay, encapsulation. So an ORDBMS allows to store, retrieve, and manage objects. Okay, along with the rows and columns. Okay. Actually, it doesn't support rows and columns. It supports objects. Okay. Object-oriented relational database management. Here it supports ORDBMS. Here it supports tabular formats, rows and columns, and also some features of object-oriented programming. Here it doesn't support. It supports only objects. It doesn't support rows and columns. Okay. That is object-oriented relational database management system. Okay. Later on, from this object-oriented relational database management system, the focus is shifted to it is shifted based on use cases. That means how we handle the data. It depends upon the how we handle the data. That means for unstructured, semi-structured, we started using NoSQL. Okay, NoSQL we use for unstructured and semi-structured. Okay, and if it is time series database, we use time series DBMS, and for interconnected data, social networks, or graph databases, we use graph database, and for cloud we use Cosmos DB and Databricks and snowflakes. Okay, so that is the topic here. We ended with the object-oriented relational database management system, but our concern is with the relational database management system. SQL Server is a pure relational database management system. It supports some features of object-oriented programming. That's why we call it as a partial object-oriented relational database management system also. Okay. Next thing is OLTP and OLAP. Okay, those things we can discuss in the next class. Okay, let's stop here. Okay, and let me know if you have any doubts. Do you have any doubts? Let me know. Anybody?
So just one question. This course is completely based on SQL Server, right? So we'll be writing a code on SQL Server only, right?
Yes, exactly. SQL Server development. It is related to SQL Server.
Okay.
Okay. Next.
So like PLSQL also it will cover like something.
See, PLSQL is Oracle. Here we use TSQL, Transact SQL.
Yeah, so that is similar to that or some.
See, in relational database management system, SQL is a standard one. In order to write programs, we use TSQL, like PLSQL in Oracle. We have TSQL in SQL Server. It is related to programming. That also we cover. Okay. Any other doubts you have?
So like this running notes you will give or like classroom video, right? Recorded.
Yes, recorded videos will be given access, and also daily notes also will be provided. Okay.
So is there anything like DBA related things also?
DBA, if you see the course content, no, have you gone through that course content?
Yeah, I have checked here.
At the end, we wrote some DBA related tasks also. You will get some idea about that DBA related topics are also.
Backup recovery, right? Backup
yes,
recovery.
exactly. And SQL agent also. We will cover that also. Okay.
So like suppose if I'm attending the class, can I have some get experience and search for the job like a 5+ year in the SQL Server development? Is it fine after that?
No, I didn't get you. What is that exactly?
So like I'm asking like after completion of this course, I'm eligible or can I have some confidence to crack the interview of the 5 year of experience in the SQL Server development?
Definitely you will get that command on SQL Server, because see, everyday classes I teach, but it is up to you to practice that, right? So the more you practice, the more command you get, right? So definitely you will crack the interview. If you understand the subject clearly, then you will crack the interview, no issue.
Because in the interview that they will only mostly they will ask for the query
Practical
and
oriented also, query related.
query
Ah,
related things mostly.
yes, that's what I'm saying now. So whenever we cover one topic, we complete one topic, we have to practice that immediately. And the more you practice, you get that command. Okay. Then you feel easy to write the queries also. It's not a rocket science. It is very simple one. But the thing is, you need to practice. That's it.
Sir, in this in like course content, like normalization is not there, right? I think
See,
it's
normalization, denormalization, if we have
basic
time that
properties.
we can discuss later, but it is not mentioned in that topic because
This is
usually,
before starting, like this is the introduction time only, right? Acid property and the
yes,
normalization.
yes. If you are strong in fundamentals, then you will understand SQL Server easily. Okay, then we can discuss remaining topics.
I know DB2 because I work on DB2, so it's a
Okay.
similar to most of the things, but
Yes.
I want to some like move in the
Mm.
SQL Server side or SQL Server DBA side. So I was thinking to.
Well, no issue. See, if you want to completely move to DBA, understanding this SQL development, it is okay, good. You can show it that in your profile also. Then remaining concepts, what are there in DBA that you can learn later. But it gives an added advantage, right? So that is the thing.
So like if you compare to Oracle and this SQL Server, so something syntax is different, right? As
Most of the syntaxes are same here. Actually, in
Mhm.
Oracle, only few differences you find. Okay, but the standard one is SQL. Wherever you go, SQL is same for all the RDBMS systems. Okay.
Like if you learn like SQL Server, then MySQL and Oracle will be the same as it is. Something will be changed, right? Syntax.
Yes, almost same,
And the PLSQL will be the separate one, the part for the
TSQL.
Oracle. Yeah, for the Oracle, PLSQL will be the.
TSQL is related to programming. That also we cover. Okay, that we cover. No issue.
So do we cover any query tuning techniques also?
Yes.
Okay.
Development in the sense query related, complete query related.
Yeah.
Okay. Any other questions? Any other doubts?
So like how AI will replace the SQL Server?
AI.
Yeah.
That I already explained in the features. See here, AI also in 2025, we have to see that how they given that option AI related. Okay, that it is not yet released. Our latest version is 2022. Okay, when they release now, so then what kind of features they given in 2020, that we have to see. Okay, so understanding of concepts is mandatory. After that, when you work, you will get more experience. And AI, in the sense, it supports that nowadays everybody has that fear that replaces your jobs also. No, you don't need to worry about that. It's an added advantage having AI knowledge. Okay. Any other questions? Anybody? Is it okay now?
Yeah, fine, sir.
Okay, fine. Okay, let's see. Let's continue this class. Okay, tomorrow. So tomorrow will be third demo. Okay, we will meet tomorrow then. Okay, bye. Good night.